All right. So this one's number 2. The hydrogen dioxide decomposes to produce oxygen gas and the hydrogen monoxide. This actually was a mistake. Okay. In class, I shortened this to hydrogen gas. Okay. So now this, the hydrogen monoxide, this has to do with prefixes now. So short review of prefix. Mono equals 1. Di is equals 2. Tri is 3. Tetra equals 4. Penta equals 5. And, usually, unless they want to get real fancy, they don't go above 5. So this one says dihydrogen. So you should know the element hydrogen is H. Di would be 2. Dioxide. So you should have a clue at this point. Oxide really is oxygen, and another di would make this O2. Okay, which this is hydrogen peroxide, which is something you get from the store. Decomposes. Decomposes to produce. To produce is always the arrow, so we're just going to draw the arrow right there. Oxygen gas, so we're going to put O. But remember, most of the time when they're saying gas, they want you to go ahead and put a little 2 there. Unless it's a noble gas or carbon dioxide. But if they say gas, they want you to know that it's diatomic, 2 atoms connected, same atoms connected together. And hydrogen gas, the same thing. Okay, so that was step number 1. We translate it the right way. Step 2, we're going to balance it. So this right here is okay, so think about it like this. You have 2 different atoms. They are connected together in a compound. But 2 different elements, sorry, but you have 2 atoms of those 2 different elements. So I'm just going to put an H down here. I'm just going to put O connected to itself down here. And yeah, this is a funny looking way to do it, but this is our molecule. Okay, then we have O2, which is oxygen combined to itself. We have H2 combined to itself. So now we need to see if it's following the rules of chemical reactions, law of conservation of mass in nature. So 2 hydrogens here, we have 2 here. We have 2 oxygens to begin with, we have 2 at the end. So there is actually no need to double or anything that we have. This is a direct split up of these atoms. So when that happens, does your reaction have a large molecule falling apart to make several small ones? Yes. This is decomposition. So that's what this is going to be. Decomposition. Okay. So, and by the way, since we didn't need to duplicate any of these amounts, it's like saying if you were cooking, you only needed a cup of one thing and it produced everything you needed. We're just going to put 1, 1, and 1. Okay, so now we have to do the last step is what is oxidized, what is reduced. Okay, so think about the charges from the periodic table. Hydrogen, when it gets with nonmetals, wants to act like it's a metal. Hydrogen has a charge of +2 or +1. And we're not going to worry about specific, charge numbers and stuff. We're just going to go by what we see on the periodic table. Oxygen has a charge of -2. Because, you're technically supposed to balance these out, but, we're not going to worry about that. Okay, as they split up, they go into being neutral. Okay, neutral atoms. So let's look and see what happened here. Okay, we're using the scale. We have oxygen gas, We have hydrogen gas. So oxygen went from being, now this only works if you have single atoms involved. If you have a bunch of compounds that just switch, you would not have something oxidized reduced because they're they're always going to be an ion form. But and then we'll talk about that with double replacement. So oxygen went from -2 to 0, and hydrogen went from positive +1 to 0. Okay, so basically, looking at this, which one was reduced? Okay, if you go from -1 to 0, you're actually going up. But if you go from 1 to 0, you're going down. So in this case, the hydrogen gas was reduced. This is the one that actually picked up some extra electrons, and oxygen was oxidized. Okay, and that's the end of that right there for you.